All right, let's dive in. We're going to talk about bridges today. But not just any bridges. We're talking about how one of our most important inventions went from being literally woven out of grass to having a mind of its own. It's an incredible journey, so let's get right to it. So right off the bat, I've got a question for you. How can a bridge be alive? I mean, that sounds a little crazy, right? Like something straight out of a sci-fi movie. But what if I told you that the very first bridges actually were alive? And get this, the bridges of the future are gonna be alive too. It's a wild idea, and it all starts with a problem that is fundamentally human. Just think about that for a second. For our ancestors, a river, it wasn't just some water you had to get across. No, it was a wall, a massive, impassable barrier. It was the end of your world. It cut you off from food, from other villages, maybe even from your own family. And that desperate need to connect, to get to the other side, well, that's what kicked off one of the greatest engineering stories ever told. Okay, so let's start at the very beginning. With those first bridges, they weren't made of steel, they weren't made of stone, they were made of something way more fragile, and honestly, something way more amazing. You heard that right. In the Andes, the Inca didn't have steel for their massive empire. They had grass, coya grass, and with it, they built these incredible suspension bridges. I want you to really picture this. Thousands and thousands of blades of grass, all braided together by hand, creating these massive ropes, some of them thicker than a person's torso. And these grass ropes were strong enough to stretch across these terrifying canyons, carrying people, goods, everything. And here's the key idea, the thing that makes this so special. We call it organic engineering. Because this wasn't some project you just build and then walk away from. No way. The bridge's very life depended on a constant loop, a partnership between people and nature. So these bridges, they weren't just objects. They were treated like members of the community. Because if the people stopped caring for it, the bridge would actually die. I mean that literally. Every single year, everyone from the surrounding villages would gather for this big ceremony. They'd take down the old bridge and weave a brand new one. It wasn't just maintenance, it was a ritual. If they ever stopped that ritual, the grass would rot, the bridge would collapse, and that vital connection would be gone. But of course, human ambition is a powerful thing. We didn't just want to build a bridge that lasted a year. We wanted to build something that would last forever. We wanted to conquer the river, not just cooperate with it. And that meant moving on from living grass to something we thought was eternal, stone. And who mastered stone better than anyone? The Romans, of course. Their secret weapon was the arch. Now, the physics might sound complicated, but the core idea is so simple, it's genius. It's a total masterpiece of physics. Here's a simple way to think about it. Imagine two people leaning against each other to stay up. All their weight is pushing down, right? But because of the angle, that force gets pushed sideways into their feet and into the ground. The arch does the exact same thing. It takes all that vertical weight from people and carts and pushes it sideways safely into the ground. It's genius. And how effective was it? While structures like the Pont du Gard are still standing 2,000 years later. This just perfectly captures the Roman mindset, doesn't it? They weren't building for next year. They were building for the next millennium. So while the Inca bridges were reborn with the seasons, these Roman giants just stubbornly stood there, surviving floods, wars, even the fall of their own empire, all through sheer brute force engineering. Incredible. And then, when you look at it this way, you can really see how things evolved. For thousands of years, we went from grass to stone. A huge leap, for sure. But then, the Industrial Revolution hits. And with new materials like iron and steel, the pace of change just explodes. Everything gets faster. Suddenly, with iron and steel, strength didn't have to mean giant, heavy blocks of stone anymore. Engineers figured out they could use trusses. You've seen them, those complex webs of triangles. A triangle is just the strongest, most stable shape there is. And by linking them all together, you could create bridges that were unbelievably strong, but also way lighter than a stone arch. This was the dawn of the machine bridge, and it let us cross spans the Romans couldn't even have imagined. Okay, so for almost all of history, bridges have just been passive. They're silent giants, just sitting there, taking the load. But that is all changing right now. The bridge is starting to wake up, it's getting a brain. And how does it get that brain? With this. Thousands and thousands of tiny sensors. We're embedding them right into the concrete and steel as the bridge is built. It's basically like giving the bridge its own nervous system. So what does this nervous system do? Well, it feels. It can feel the stress of heavy traffic. It can feel the vibrations from a strong wind. It can even feel the temperature changing. Think of it like a Fitbit for a bridge. It's tracking its vitals 24/7. And the best part? It can detect a microscopic crack, something no human eye could ever see, long before it has any chance of becoming a real problem. And it's not just the brain that's evolving. The bones are too. For more than a century, steel was the undisputed champion of strength. But look at what we have now. Carbon fiber. This stuff is 5 times stronger than steel, but it's so light you could literally pick up a beam of it. That completely changes what's possible in design. And all of this, the sensors, the new materials, it's leading us to something truly mind-blowing. This is where our story comes full circle. Remember those living grass bridges? Well, we're going back to that idea. But now, we're doing it with some seriously futuristic tech. The future of bridges isn't about just building them. It's about growing them. I mean, we are already 3D printing bridges using shapes inspired by nature, like bone, to make them super strong but use less material. We're developing bridges that can actually harvest energy just from the vibrations of cars driving over them. But the wildest one of all? We are creating concrete that can heal its own wounds. Yeah, I know, it sounds impossible. But here's how it works, and it's actually beautiful. First, a tiny crack forms and lets a little water in. That water acts like an alarm clock, waking up these special bacteria that we've mixed into the concrete. Once they're awake, they start to eat a food source we put in there for them, and their waste product is limestone, actual rock. And that limestone fills the crack from the inside out. The bridge is literally healing itself. It's growing its own scar tissue. This really says it all, doesn't it? The bridge of the future isn't just built, it's grown and optimized. We're shifting from just being builders to being, well, almost gardeners of our infrastructure. We're creating things that aren't just objects anymore. They're becoming organisms. And that brings us right back to where we started. It's this beautiful circle. We began with the Inca grass bridge, which was alive because of constant human care. A community keeping it alive with their own hands. And now, we're designing a bio-bridge that's also alive. But this time, it's kept alive by technology that's woven right into its DNA. So, from simple grass to eternal stone to industrial steel, and now to self-healing, intelligent structures, it's been an amazing evolution. Our bridges are no longer just tools we use. They're becoming our partners. And that leaves us with a really big, exciting question to ponder. What are we going to build together next?